Welcome to this video on the Belle Croissant Lyonnais IT software solution. In this part of the walkthrough, we will cover installing development tools and building our database, UI, and tests. I am Mrs. Zuhra will show how to solve database validation. Step 23 involves checking for invalid quantities in our staging data. We use a SQL query to identify any null values or quantities less than or equal to 0. We expect 0 rows here. Next, in step 24, we check for invalid prices. This SQL script cleans up formatting by replacing currency symbols and commas before conversion. Again, we expect no rows returned. Step 25 focuses on transaction consistency. We verify that each transaction ID is associated with only one customer, date, payment method, and channel. We expect 0 rows returned. For step 26, we create an order date value. If your CSV has separate date and time columns, use this approach to combine them into a single date-time value. Step 27 ensures each transaction has only one record in the orders table. If your data lacks a total underscore amount column, use the provided script to aggregate the necessary values. In step 28, we insert each sales row as an individual order item using the provided script. Remember, avoid using identity underscore insert unless you have specific identifiers to preserve. Part K starts with step 29, where we verify our data import by counting the rows in each table and comparing them against the original source data totals. Continuing with step 29, we also check the total number of distinct transactions in the staging area to ensure our row counts align correctly. Step 30 checks for orphaned order records. This ensures all orders are properly linked to a customer. An empty result set is expected. Similarly, step 31 identifies orphaned order items. We confirm that every item correctly references both a valid order and a valid product. In step 32, we compare order totals with the sum of order item totals. Review any returned rows, as minor differences may be due to legitimate taxes or adjustments. Step 33 allows us to display a sample of our joined data, giving us a clear view of how orders, customers, and items are linked together. Step 34 involves checking our database constraints. We verify that prices, costs, and ages are not negative. All these checks should return 0 rows. Finally, Part L covers adding recommended indexes for foreign key columns. This optimizes database performance and completes our import process. Moving on to Part M, we need to reset our identity values. After performing an identity insert, it is important to synchronize the identity seed with the current maximum values in our tables. Here, we reset the identity value for the products table. We declare the maximum product ID and then use dbcccheckident to reseed the table identity. Next, we perform a similar operation for the customers table. This ensures that new customer records will receive the correct subsequent ID numbers. We repeat this process for the orders table to synchronize its transaction IDs, keeping our database keys consistent after the bulk import. Finally, we reset the identity values for the order items table. This sequence ensures that all future inserts will generate IDs higher than those already imported. Part N addresses staging tables. Once you have verified your data is correct, you can choose to remove these temporary tables to clean up your environment. For Part O, we create a credentials file. Save this as session3_databasecredentials.txt, and be sure to use the correct authentication method for your specific database configuration. Lastly, Part P provides a final verification checklist. Use the session3_databaseverification.sql file to confirm that your database is fully prepared and correctly structured for submission.